Download this code from codegive.com, link in the description below. P-test coverage, a deep dive into code coverage testing with no source code access. This tutorial explains how to tackle the challenge of measuring code coverage in P-test when you don't have direct access to the source code. This situation often arises when working with third-party libraries, compiled modules, or when testing systems where the source is obfuscated or unavailable. We'll focus on techniques to assess coverage indirectly, primarily using the pytest-cov plugin and examining bytecode. Understanding the problem, the source code barrier. Pytest-cov normally works by instrumenting your source code. It adds probes that track which lines are executed during tests. Without the source, this instrumentation is impossible. However, we can still gather partial coverage information. The key is understanding that the bytecode, the compiled form of your code, still holds execution information. We can't directly map line numbers to the original source, but we can still assess how much of the bytecode is executed. This gives a less precise, but still valuable, indication of coverage. Prerequisites Python ensure you have Python 3 installed. Pytest pip install pytest. Pytest-cov pip install pytest-cov. Scenario: testing a mysterious library. Let's assume we're testing a mysterious library, mysterious_lib.so, a shared object file, common in C extensions. We have no access to its source code, but we do have a set of tests. 1. Setting up pytest-cov for bytecode coverage. The crucial part is configuring pytest-cov to target the bytecode. We do this using the -bytecode flag. This tells pytest-cov to analyze the bytecode instead of the source. Note that this might not cover every aspect of the library, particularly if it uses intricate low-level operations or native code. *-cov equals mysterious_lib, specifies the target for coverage analysis, the library name. It might need to be adjusted depending on your setup. *-cov report term missing, this generates a report showing the lines not covered in the terminal, which is particularly useful when source code isn't available. You can use other report formats like HTML or XML as well, but the term missing is most helpful in this context. *-bytecode, this is the key. It instructs pytest-cov to use bytecode for coverage analysis. 2. Writing test cases, example. Even without source, we can write meaningful tests based on the library's documented functionality or observed behavior. Let's say mysterious_lib has a function calculate_something. 3. Running pytest and analyzing the report. After running the command above, you will see a coverage report in your terminal. The report will show the percentage of bytecode instructions executed. Because we lack source, the report will be less granular than a typical source code coverage report. It won't show line numbers in the conventional way. Instead, it might provide a general coverage percentage for the library's bytecode. This percentage indicates the overall execution of bytecode instructions during tests. Example report, simplified. This simplified example indicates that 75% of the bytecode instructions in mysterious_lib were covered during the tests. The missing 25% might highlight areas of the library needing further testing or point to potentially unused code sections, although pinpointing the specific parts will be challenging without source code. 4. Limitations and considerations. *precision bytecode coverage is less precise than source code coverage. It gives a general overview but lacks the line-by-line detail. Debugging identifying precisely which parts of the bytecode remain uncovered is harder without source code. You'll have to rely on debugging techniques at a lower level, example debuggers that operate on the bytecode. Complex libraries. For very large or complex libraries, the interpretation of bytecode coverage might be less straightforward. Advanced techniques. Disassemblers. Tools like dis, Python's built-in disassembler, can be used to inspect the bytecode, though interpreting it requires deeper understanding of the Python virtual machine. Decompilers. In some cases, decompilers, with varying success rates depending on how the code is compiled, might help partially reconstruct the source code, allowing for more detailed coverage analysis. However, the decompiled code might not be entirely accurate. Conclusion. While lacking source code significantly limits code coverage analysis, pytest-cov with the -bytecode flag offers a valuable way to get a high-level overview of your test's effectiveness when dealing with external or compiled libraries. Remember to interpret the results cautiously, understanding its inherent limitations, and leverage additional debugging or decompilation techniques if further insights are needed. This approach is a powerful tool for improving the quality of testing in situations where full source access is not possible.